The following video is on graphing derivatives. Given the graph of f, seen to the right, sketch a graph of the derivative of f. The first thing that we're always going to do is find any points with horizontal tangent lines. In other words, any points where the derivative is 0. In this problem, we see that there's one point when x equals 0 that we have a horizontal tangent line. The second step is to look everywhere else and see if the slope is positive or negative. So here we see that we've got some positive slopes as we move to the left of 0. And as we move to the right of 0, we have more positive slopes. So if we draw a number line and label it as f prime, at 0 the derivative is 0, but everywhere else the derivative is positive. Furthermore, we see that the slope is steeper as we move away from x equals 0 and flatter as we get closer and closer to 0. And that happens both above and below 0. So back to our number line, as we move further away from 0, f prime is going to be bigger. As we move closer to 0, f prime is going to be smaller. So now we're ready to come up with a sketch of the graph of the derivative of f. So notice that the function that I've drawn here is a big positive number as we look at very negative values of x. It gets closer and closer to 0 and we get a smaller positive number until we get to 0 where it's actually equal to 0. Then as we move to positive values of x, we start at small positive numbers and we move up to big positive numbers. So this red function here is the derivative of f. Let's try another one. So here we see a function f of x and we want to sketch a graph of its derivative. The first step is to find any points where we have horizontal tangent lines. So it seems like f prime of x equals 0 at x equals 1.5 and 2.5. We draw our number line and we label 1.5 and 2.5 on it. And then we look everywhere else to see where the function is increasing or decreasing. Notice that this function is increasing everywhere below 1.5 and decreasing in between 1.5 and 2.5, and then increasing greater than 2.5. Furthermore, the function is steeper the further away we are from the two horizontal tangent lines. So going back to our number line, we have a positive value less than 1.5 and a positive value greater than 2.5, but a negative value in between 1.5 and 2.5. So if we wanted to sketch the derivative, we have two values where the derivative is equal to 0. That happens at 1.5 and 2.5. And we know that the curve is going to be positive. The y value is going to be positive if we're less than 1.5 and if we're greater than 2.5. So remember, the derivative, the y value of the derivative, are the values of the slopes of the original function. Everywhere in between 1.5 and 2.5, the y value of the derivative is negative. This is just a sketch, however. Let's try another problem. This one asks us to go backwards. So we're given f prime, and we have to figure out which of the following functions could be the graph of f. So looking at f prime, we see 3 points where f prime is equal to 0. Those are going to need to correspond to horizontal tangent lines. So when x equals -3, 6, and 10, we're going to have horizontal tangent lines. Everywhere else, f prime is either going to be positive or negative. So notice that below x equals -3, we have that the y values of f prime are negative. In between -3 and 6, notice that the y values of f prime are positive, and in between 6 and 10, notice that the y values are negative, and greater than 10, the y values are positive. So we can add those to our number line. Now remember, if we're going backwards to f, these represent the slopes. So the slopes are going to be positive or negative according to this number line. That means that f is decreasing from negative infinity to negative 3 and from 6 to 10, and increasing from negative 3 to 6 and from 10 to infinity. So now let's go and look at these graphs and see if we can find the right answer. Notice that for a, at x equals negative 3, it's not horizontal. We said that we had to have a horizontal tangent line at x equals negative 3. So a is not the correct answer. Once again for d, at x equals negative 3, it's not a horizontal tangent line, so that's not the correct answer. And same with b. At x equals negative 3, it's not a horizontal tangent line, so that is not the correct answer. E, however, we do have horizontal tangent lines at negative 3, 6, and 10. Now let's look at increasing and decreasing. F needs to be decreasing from negative infinity to negative 3, increasing from negative 3 to 6, decreasing from 6 to 10, and increasing from 10 to infinity, which indeed it is. So E is most likely our correct answer. Just to be sure though, let's look at C, the last option here. Notice that we do have horizontal tangent lines at x equals negative 3, 6, and 10. So far so good. But notice that our function is increasing from negative infinity to negative 3. And that is not what we were supposed to have. We were supposed to have that it was decreasing on that interval. So C is not the correct answer. And we are now certain that E is the right answer. Let's do one more example. So here's a curve which we're calling f of x. And let's try to graph the derivative. So the first step is to find all the points, all the x values where we have horizontal tangent lines. It looks like f prime equals 0 when x equals negative 1, positive 1.5, and positive 3. So we put those numbers on our number line, and now we figure where our function is increasing and decreasing. It looks like it's increasing less than negative 1, decreasing between negative 1 and 1.5, increasing between 1.5 and 3, and decreasing everywhere after 3. We put those values on our number line, and now we're ready to sketch. So our derivative is going to be equal to 0 at negative 1, 1.5, and 3. Our derivative is going to have to be positive, so the y values are going to be positive, less than negative 1, and between 1.5 and 3. And everywhere else, the y values are going to be negative. So connecting the dots in that way, we see that we can get a curve sort of like this. And once again, this is just a sketch, but this is a pretty good approximation of what the derivative will look like. It won't be perfect, but please do try to get the general idea where f prime of x equals 0, where it's increasing, where it's decreasing, and where it does not exist.